Welcome to the Quiz 2.10 review on factoring perfect squares and differences of squares. We're going to go through the 5 questions that are similar to the 5 questions on the quiz. So for question number 1, we are just asked to factor. So here's my direction. It says to factor. Now notice the expression that we're given is a trinomial because there's 3 terms in the expression. So when we have 3 terms, we have a trinomial. When you have a trinomial, this tells us that we want to look for perfect squares. Okay, I've got my perfect squares chart over here in the top right corner, so I can help myself factor. So we look at the first term, remember, and the last term, and we want to find what A is and what B is. Okay, so I'm using the format down here. Here are my formulas. Okay, notice that I have a minus and a plus sign. So this tells me I'm going to be using this second equation here with this formula. Okay, so the square root, remember we take the square root of m squared. The square root of any variable squared is just the variable. So my A is going to be m. And 25, well 25 is a perfect square if you need to use your chart. The square root of 25 is just 5. Okay, now that I have my A and B, I can go ahead and I can plug those right into my formula. So my formula is A minus B all squared. My A was m, my B was 5. I'm just substituting in those values. There was my m for A, and I substituted that in. And then my B was 5, and I substituted that in. So that is it. M minus 5 all squared. That is the answer for question number 1. We've successfully factored that trinomial. All right, so now would be a great time to pause question number 1. We're going to move on to question number 2. So in question number 2, it asks which trinomials are perfect square trinomials, and select each correct answer. So notice we're given 4 different trinomial problems, and we want to know which ones are perfect squares. So they're all trinomials. They all have 3 terms, 1, 2, 3, 1, 2, 3. You can see that they're all trinomials, so I can't eliminate anything that way. Now we're going to go ahead and find our A and our B for each of these terms, or each of these problems, expressions. I'll put this one down here. All right, so notice all of my first term, they're all k squareds. So the square root of k squared is just k, so my A is going to be k in every example. My B is what I need to look at next. So here I have 25, the square root of 25. If we use our chart, square root of 25 is 5. Here I have 49, the square root of 49, if I use my chart, is 7. I've got 121, the square root of 121 is 11. And then the square root of 169 is 13, which is right there. Okay, so that's where we're getting those values. You can use your handy chart. That way you don't even have to plug everything in your calculator. And now we have to test. Okay, now remember that the middle term, so this term right here, this is what we want to test to see if it makes sense for each of these problems. So we want to grab my pen here. We want to take 2 AB and we want to check to see if it actually equals this middle term right here. So if I take 2 and I multiply it by my A was K, and my B was 5. Well, 2 times 5 is 10, 10K, that equals the 10K here. So this first one, this is, in fact, a perfect square trinomial. So we're just going to keep doing that for each problem. So I want to test the second one. Okay, so is the middle term really going to be 9K if we have a perfect square trinomial? So I'm going to take 2 and I'm going to multiply it by my A, which was K, my B, which is 7. 2 times 7 is 14. well, 14k does not equal 9k, so this one is not going to be a perfect square trinomial. And then we're just going to continue this process. So the third one down, I'm looking for 22k. So 2 times a, my a was k, my b was 11. 2 times 11 is 22k, so that one is true. And then lastly, I'm looking to try to equal 13k. I'm testing 2ab, so 2 times my a, which is k, times my b, which is 13. 2 times 13 is going to give me 26, and I still have that k. That does not equal that 13 that was there, so that is not a solution. All right, so you can see here that choices A and choices C were correct answers. Those are in fact perfect square trinomials because they satisfy everything from our formula. All right, so you can go ahead and pause, answer question number 2 on the quiz, and then we're going to get started on question number 3. So question number 3 asks us to factor completely, and it wants us to express our answer in the form AP plus B all squared. So our answer is going to be in this form. All right, now notice here, I have a trinomial. I've got 3 terms, 1, 2, 3, so that's why we're using our perfect square trinomials formula here. Perfect squares trinomial. Okay, now I want to test, I want to find that a squared, okay? I want to know, well, what is just a? Remember, we're just trying to find what a is, and we're just trying to find what b is. So we take the square root of that first term to find a. Well, 64, if I look over here, 64 matches up with 8 squared, so the square root of 64 is 8. And remember, the square root of any variable squared is just the variable itself. So my a is going to be 8n. And then likewise, we test, or we find our b value by taking the square root of our last term. That last term is 25. I match that up in my chart. Square root of 25 is 5. So now I have my a and b. Notice I'm going to use this formula right here to factor completely. A plus b all squared. My a, in this case, using my highlighter here, my a is 8n, so I'm going to substitute that in. And then my b is 5, so I'm going to substitute that in. All squared. And I've got my answer. We are all set for question number 3. Now the only difference up here, if you're wondering why this was AP and not just A, well, that's just because in this first term this time we had a number and a variable together, where all the other examples that we were looking at were just the variable. So there's just going to be, you're going to have a coefficient and a variable together in that first term. All right, so that wraps up question number 3. We're going to move on to question number 4. Now this time I notice, oh wait, look at, I only have 2 terms. So when we have a binomial and we're trying to factor, and you only have those 2 terms, it's a binomial. This is when we want to check for the difference of 2 squares. All right, and I have my formula down here. So we're going to test and make sure that these are both indeed perfect squares. So we can go ahead and take the square root of this first term to find our a, and then we can take the square root of the second term to find our b. So the square root of 81, I can go find 81 in my chart, matches up with 9 squared, so the square root of 81 is 9. And remember, when we're taking the square root of a variable raised to the exponent. That exponent needs to be even, and we just divide it by 2. So 16 divided by 2 is 8. Okay, so 16 divided by 2, that's how I got the 8. I'm going to make that a little bit clearer as to what I'm pointing at. There we go. All right, so likewise in my second one here for B, I'm going to change the color here so we match that up a little bit better. 49, find that in my chart, that matches up with 7. The square root of 49 is 7. And then 36, to get that reduced after we take the square root of it, z to the 36. The square root of that we divide by 2. So 36 divided by 2 is going to be 18. So that's going to be z to the 18th. Okay, so I have my A, I have my B, and now we can go ahead and use our handy dandy formula here and substitute in my values. So for the A, we're going to substitute in that 9z to the 8th. And then for our B's, here's our B's, we're going to go ahead and substitute in that 7z to the 18th. And there we have our factored answer. We are all set for question number 4. We're going to go ahead and move on to question number 5, our last question. So question number 5 says, which expressions are differences of squares? And we need to select each correct answer. So remember, differences of squares, a couple things that we have to do. Check to make sure it's a binomial. And it's the difference, so you want to check to make sure it's a subtraction problem. Okay, and then lastly, both terms need to be perfect squares. So those are my checks, okay? So these are all binomials. They all have 2 terms. 1, 2, 1, 2, 1, 2, 1, 2. Subtraction. Number 1, I'm subtracting. Number 2, oh, look, I'm adding. So this is not going to be a difference of 2 squares. My last 2, I'm subtracting. Okay, so those 3 meet the first 2 criteria. Last criteria, both terms need to be perfect squares. So let's take a look at this first one. So 25v squared, I know that v squared is a perfect square because it's an even exponent. The square root of 25, oh look, 25 square root of 25 is 5. So that is awesome. And then we need to check for the b term. It's a 1. Square root of 1 is 1. It's itself. So this one checks out. That is in fact a difference of squares. Okay, so we're going to go ahead and test this third one. Z squared, well, we know that the square root of any variable squared is in fact a perfect square, so that's great. But then this guy, 29, if I come to my chart, I've got 16, 25, 36. I don't see a 29 in there. This is not a perfect square. So this is not factorable. This is not factorable by the difference of squares. Sorry about that. Okay, sorry about the toddler interruption. All right, so the last one to check. Let's check the b squared. We know that any variable squared is going to be a perfect square, so that's good. And then we've got 169. Oh, 169. Oh, awesome. In a minute, Mama's doing a recording right now, okay? Someone's excited. Her Cinderella dress is clean, so she gets to wear it. All right, So that last term, 169, it is a perfect square. The square root of 169 is 13. So this, in fact, is the difference of squares. Okay, so A and D would be the correct answers. Hopefully this helps you complete your 2.10 quiz. Good luck, and we'll see you next time.